Problem 1, we have translate. The product of 5 and y is less than 30. So I want to take this expression here that's written in English words and translate it into an equivalent expression written in symbols. So when I say the product, I mean multiplication. The product of 5 and y is 5y is less than, so I'll use my less than symbol, 30. So this is the equivalent expression written in symbols to this expression that's written in words. The product of 5y is less than 30. Now with these inequality symbols, they always point to the smaller of the two quantities being compared. So if I'm looking at the quantity 5y and the quantity 30, the inequality symbol tells me that 5y is the smaller of those two quantities. So I can read this 5y is less than 30. Here's our next problem. Expand and simplify. I have an exponent here of 3, a base of 4, and by definition, an exponent of 3 tells me you use this base as a repeated factor 3 times. So I'm going to multiply 4 times 4 times 4. So exponents stand for repeated multiplication. 4 times 4 is 16, times 4 will be 64. So 4 raised to the third power is the same as the number 64. So 4 is the base, 3 is the exponent, and that exponent 3 tells me that I want to use that base 4 as a factor repeated 3 times. 4 times 4 times 4. Here's our next problem. Simplify 5 plus 2 times 6. My rule for order of operation tells me I have to multiply before I add when I have a choice between multiplication and addition. So I begin this problem by writing 5 plus 2 times 6 is 12. Now I can add 5 and 12, and I end up with 17. Now, as you go through and work these problems, some of these will be real simple problems for you. You want to show your work like we're doing right here. Write complete lines out with equal signs like this, and don't do a lot of little side calculations and then just write the answer. In algebra, it's the form of these solutions that's actually more important to us than the answer itself. Let's try another problem. Problem 4, we want to simplify 4 plus 8 divided by 4 minus 2. My rule for order of operation tells me that I need to do division before I do addition or subtraction. So I'm going to begin by doing this part of the problem. I have 4 plus 8 divided by 4 is 2, subtract 2. Now when I have all addition and subtraction, the rule for order of operation tells me to move left to right. So 4 plus 2 is 6, subtract 2, and then 6 subtract 2 is 4. So that rule for order of operation, that's a guide that tells me how to go about simplifying expressions in algebra. This expression right here is equivalent to just the number 4, and I find it by simplifying according to my rule for order of operation. Here's another one. Let's simplify 10 subtract 2 times the quantity 4 times 5 minus 16. My rule for order of operation tells me to start within the innermost parentheses first, so I have to begin by simplifying this. So it's 10 subtract 2, and notice I write everything else down, and then I simplify. Inside the parentheses, I have to multiply before I subtract, so 20 subtract 16. This will be 10 subtract 2. Don't weaken here and subtract because I have to do multiplication here before I do subtraction. That's the rule. 20 subtract 16 is 4. Now, 10 subtract 2 times 4, I need to do this multiplication. I have 10 subtract 2 times 4 is 8, and now finally 10 subtract 8 is 2. So that's the way you do this problem. If you think, well, maybe I'll just subtract 2 from 10 to begin with, you'll get the wrong answer because the rule for order of operation says that we need to go inside the innermost parentheses first, then I do multiplication and division before addition and subtraction. So I need to work inside here. That simplifies to 4. Now I have multiplication and subtraction. Multiply first, then subtract. The answer is 2. Let's do one more of these. 3 to the 4th power plus 4 to the 2nd power divided by 2 to the 3rd power minus 5 to the 2nd power. So my rule for order of operation says to take care of exponents before I do any addition, subtraction, multiplication, or division. So 3 to the 4th power is 3 times 3 times 3 times 3. That will be 81. Plus 4 to the 2nd power, 4 times 4, that's 16. Notice I'm writing this down exactly the way it's written right here, just simplifying the expressions with exponents. 2 to the 3rd, 2 times 2 times 2. That's right, it's 8. Subtract 5 to the 2nd, 5 times 5, 25. So I've gone ahead and simplified each expression with an exponent on it. Now I'm going to apply my rule for order of operation and do division before I do addition and subtraction. So I have 81 plus 16 divided by 8 is 2 minus 25. Now 81 plus 2 is 83, and that's going to be subtract 25. And let's see, that should be 58, is that right? 5 and 8 is 13. 5 and 2 is 7, and 1 is 3. Yes, so 83 subtract 25 is 58. So that rule for order of operation, it's written in the book. It's very clear what you have to do in what order. Now, what you want to do is work enough problems so that you're programmed to operate that way. You want that rule for order of operation to be just second nature to you. So in order to get to that point, what you need to do is to work a lot of problems.